Hi guys, today this is Dr. Madhava. We are going to learn a little bit about energy and different forms of energy and how energy can be converted from one form to another. So first of all, let's understand what's potential energy. So potential energy is the energy position obtained by virtue of its height. As you can see, as I'm raising this guy up, you can see he can have more potential energy. The bar on the left indicates the energy in the form of potential energy. So potential energy can be represented in simple equation as mg into h. M is the mass of the body, g is the gravitation for acceleration due to gravity, and height is the elevation above the ground. So this is a simple understanding of potential energy. Let's look at what kinetic energy is. Kinetic energy is something that you obtain by virtue of motion. Now, if you are moving, now you can see there is some potential kinetic energy involved in it. As you can see, as this rider is moving down, so he is transforming one form of energy into another. Now, to understand this a little better, we're gonna do a simulation. Now let's look at let's keep him at certain height. Now you release him, and now what do you expect? So you will expect him to gain some kinetic energy, and then he will be converting again into potential energy. So this is a simple understanding of conversion of one form of energy into another. In this particular case, kinetic energy. But as you might have noticed, there is another form called thermal energy. Why is this coming into picture? Because, can I give you a minute? You want to figure out why this thermal energy it keeps on increasing? Because we kept what we call friction. What is friction? Friction is resistance to motion offered by the surface of contact. So let's look at why. Let's remove friction for the time being. Now you can see the only two forms of energy will be kinetic and potential, as you can see. And so he, and in this particular case, this, believe it or not, he never comes to rest because there is no loss of energy. He keeps on moving until the end of time. Now, just as we do, if we increase friction, now you can see he's slowing down. He's slowing down. I am increasing the friction here. He's slowing down dramatically. And now all the energy, all the kinetic energy is gone, and all the potential energy is also gone. Only thermal energy remains. That means he lost all his potential energy, all his kinetic energy, and everything is converted into heat. So that heat can be stored in the footboard, and his body might have heated up, and the air around it might have heated up, and the ground, the board itself might have been dented a little bit because of the motion. So the energy that he lost is in form of lot of other stuff. So energy is still conserved. As you can see, the total energy is still the same, which was the same even before he started. Even at the it is the same as the one with which he started. So the total energy will remain constant. Now let's look at another scenario where how friction affects the motion and how it slows things down. Now let's keep an object with no friction whatsoever, and then let's give it a small elevation like this. Let's keep him here. Okay. Now as the skater goes down, and when the friction is less, he will be moving quite a lot, and he will lose kinetic energy at a certain rate. Now, as if I increase friction and redo that, now he may actually stop much quicker. Now he may actually stop within our screen. Maybe not. Maybe he does. So he does stop within our screen. So that means the friction, the effect of friction is to bring bodies to rest quickly. So if you increase this friction, obviously, and you do the same experiment again, so he might actually stop within this frame, right? Because you're offering more friction, and then he will actually come to rest. And remember, in all the cases, the total energy, which is the sum of potential and kinetic energy, will remain constant. Okay, and now does it actually matter